Welcome everyone to another state-of-the-art, one-of-a-kind and first live senior on this channel live stream. May I present to you here on this all-winner D1 Xuan T-Hat C906 RISC-V core running with vector extension. Yes, they said it's impossible and upstream doesn't want it, and the RISC-V creators and people say go away with this cursed 0.7.1-draft implementation. But recurrently I spent way too much time this week, not only most time, and that is the irony, right? Previous video there below, video, my other day run, I literally spent 5 times more just to get a bloody kernel booting at all on this cursed silicon, and only some hours of making the vector extension work, right? The issue is, as per the previous video, that Alibaba, the Chinese Alibaba daughter company, a subsidiary, T-Hat Semiconductor, implemented their T-Hat C906 core with a draft extension for what SIMD, single instructor multiple data vector extensions, are. Videos on my more main channel. If I repeat everything each time, then the videos double and triple in length. Basically, more performance for processing more data with one instruction, similar to MMX, 3D Now, SSE, AVX on the x86 side, or PowerPC Ultivec. And obviously, having been donated the silicon, I obviously wanted to see this work. I'm not the first to do that here. Other people did a proof of concept 2 years ago, but then nobody cared and stuff. And so what is new with this stuff is I made this work on the nearly current, it doesn't really matter too much. I only used a 6.1 and not 6.3, or where are we even? Probably 6.39. That is minor, right? It totally doesn't matter at all. I only use 6.1. It would work with 6.3 or future kernels. I only use this kernel because that is the only halfway decent complete set of board support patches I have for this cursed Mango Pi silicon. So what I've done is I hacked, so I took also vector extension is only now with latest release candidate of 6.4 upstream. Probably, I did not check, but as far as I remember, it was merged, so like 2 years later. So what I did is I took basically the nearly latest and greatest RISC-V ISA extension enablement. And so the thing is that there are incompatibilities, right? I now become a master, not only master Jedi of 20, like 2 dozens of CPU architectures, and now not only RISC-V, like not only live on this channel, I brought to you RDNA2 high performance graphic on 64-bit RISC-V unmatched desktop years ago, as seen on Linus Tech Tips and Gamers Nexus? No, Level 1 Tech. And now RISC-V vector extension, right? And the performance improvements are dramatic on this Raspberry Pi Zero kind of silicon. Here on some quick test, we are so this is actually vectors. So we are starting out here like with string copy only in this kind of test with, the problem is this numbers are so low because the overhead is so large of just string and mem copy for a couple of bytes. But if we compare here, for example, something reasonably 16 bytes or so, it's like 3 times the performance, or 4 times, right? So if we, like here, for example, 128, yeah, so 3 times the performance, 128 string copy. I believe for mem copy it was even more dramatic. So like double and triple your performance, like your low energy IoT, DIY Tinker RISC-V performance, double, triple, or quadruple in some cases with this simple hack. The changes are not as massive. I hope this fixed file diff catches all. So what are the difference, right? And the difference are not so large, right? I showed you that in yesterday's video, or the other day's video. And now I understood and guru meditated even more details. So for all the introduction, I believe I have a RISC-V vector extension first impression video from a year or 2 ago on my more main channel, and the other day's summary, previous video. So why it does not just work is that they changed here some bits in this V-type for the element sizes here. I believe it was this one, so that is 0, 1. Of course, I naturally have both here on the screen, so they changed some bits around. They also, of course, I agree, the final draft is more complete and more polished and more powerful and so on, but nonetheless, I would have, as per previous video, preferred if they wouldn't last minute or last year made it more incompatible than it had to be. It's absolute crazy stuff. So in theory, it should be, in theory it is possible to support 0.7.1. There millions of shipping devices are out there. And even, actually, my work here is not that superfluous and stuff. Like, not only do we have millions of devices in the market this year and for years to come, I also read other Asian companies actually still create new silicon, too shocking to me and probably the greater RISC-V ecosystem. I saw on Twitter there is high performance, like many core, like whatever it was, 128 or 256 core, like maybe even dual socket. RISC-V high performance computing silicon coming still with, I can't believe it myself, 0.7.1 draft implementation this year, as crazy as it is. But that is another point. So given that most of the stuff is compatible, right? So it's like basically maybe 90% compatible, and like from the instruction encoding, so certainly it has the same set of vector registers and stuff. So most of the stuff is compatible, right? From the instructions, like maybe 90% or so is compatible, which is crazy that the creators of RISC-V did not make sure. Yes, it was not the right thing to create the silicon, but at least we have a proof of concept implementation. I appreciate that, at least. Although I believe, by the way, I found some CPU bugs while it's like, overseas YOLO. Did I mention the other day, I mentioned somewhere on Twitter or Discord or here on this channel, I forgot, somewhere I mentioned, I hope they formally verified their CPU, and as expected from overseas companies there in their garage, I think they haven't, because with my hours of tinkering, I believe I found some implementation deficiencies, if not to call it probably silicon bugs. So it's like, 0.7 draft implementation with some silicon bugs. Yay! So the changes are not that big. It's like, hey, it's like unsuccessful YouTuber totally doesn't know what he's doing, making 0.7.1 vector extension work with this 5 files changed 21. It took me probably another 6 hours to get it working. Why did it took 6 hours? Because some stuff changed more than I thought. Also, absolutely crazy stuff, right? The RISC-V ISER is hard-coded in the bloody device tree. It's like I have no words anymore, right? It's like, I was working on this stuff, I was wondering why does the vector extension not enable and come up. It's like, until I realized, like, they hard-coded, like, that is not all winner stuff, that is Linux platform enablement device tree as its finest, if you were wondering why I still dream about my unsuccessful little microkernel. Then one thing, so probably I should summarize the changes for you playing along at home. The first thing is that, so this encodings here are slightly different, whatever the case might be. So yeah, this is one bit more, this vmul is one bit more, this, so as a result, this selected element with moved one bit up, and also this is new, this vector tail agnostic, and mask is new, so we shall not set this. If you set this, you probably get an elegant instruction. Also, absolutely crazy, also new is, and that is what took like 6 hours to figure out, they added a new CSR, the VLAN in byte read here, so I hard-coded that for now. So that is a VLAN B, that is a vector length divided by 8, because vector length is bits. This implementation is 128 bits, so divided by 8, this is why vector register length in byte. So that is new. You don't see that in the old specification here, right? And so this is early on startup, right? So like if without changes, your Linux kernel illegal instruction falls on startup with, hey, CSR VLAN B, or is it illegal instruction? Maybe it is. I forgot what. I think it was illegal instruction. So yeah, I hard-coded that for now. So it is possible to derive that, right? But just as they write in the final specification, this value design time constraint in any implementation without the CSR, several instructions are needed to calculate VLAN. So you would need to set the VLAN and then determine the element set and stuff. So yeah, I understand, but it's crazy that like for years they worked on the vector extension, and then between 0.7.1 and I believe maybe it was added at 0.8, but yeah, like they worked for that for quite some time, and then it's like, hey, wouldn't it be nice to have some vector length in byte registers like due. Yeah, as the standard writes, we could compute this. I wanted a proof of concept prototype, right? So theoretically, like, what does it mean? So it means like all of these changes could be made dynamic. So like, if we wanted to support this, right, in the Linux kernel, we could have a global constant of vector ABI version, and like if it's 0, then like, given we wouldn't even need that, right? We could most of the stuff I've done would even work on, like, except this, that shouldn't be hard-coded. But the other changes would also work on Silicon, right? So then here, for example, is this VSET VLI. So this this is tail and mask agnostic. These are the new bits here in this somewhere here. Agnostic. Come on, where are you? Where is my +1 when I need it? So this is added to the later work. Agnostic should be somewhere here. Here, vector mask. So these 2 bits in the instruction in the V-type register layout that they added after 0.7.1. And so they need to be 0, right? I need to review if this is 100% correct for executing on 0.7 and 1. So basically, like this again, illegal instruction falls with this bit set. Otherwise, the other stuff is mostly like, we are lucky that for element 8 and mask 8, I need to double check, but I believe the instruction coding is accidentally identically, hopefully, hopefully at least. But hey, it works. So yeah, some stuff needs review. Then other changes is that they also added in the context switching code here in this vector state save and restore, it also surprise illegal instruction faulted, right? Like 6 hours illegal instruction faults. Yay. So it should work. So the upstream code is using a CSR-V CSR, and like some of the stuff really surprises me. So that is a vector state control, whatever the official name for, oh, come on, VCS, what's his name? VCSR, come on, VCSR. They added this, also obviously after the 0.7.1 draft work. And what this is actually a unified register merging the VSET and so this vector control and status register, that is merging, simply merging. Again, a register not present in the 0.7.1 draft. This is merging the bits of the fixed point saturate flag and fixed point rounding mode, which are only 3 freaking bits. And the point of this is probably mentioned here, is the vector fixed point rounding mode is given in a separate CSR address to allow independent access, but is also reflected as a field in VCSR. The vector control and status register is so combining this VXRM, this rounding mode, and VX vector extension saturation separate C's are, it's just freaking 3 bits, right? So it's 2 bits in one freaking register of, hey, 64-bit register, but 63 bits unused. It is a little bit silly. I understand why they did this. Like, so they combine this, right? So this, as the name implies, the VXRM fixed point running mode controls the running mode of your vector operations, and the VX set saturation flag only, so that is a flag, and that only indicates whether the last instruction, whether a fixed point saturation occurs. Like you adding values, like you work with image and audio data, you add 2 numbers, like you have 8-bit numbers, they go from 0 to 255, 2-bit binary stuff, right? Wikipedia article. And so you add stuff like normally, like in old-fashioned microcontroller integer stuff that would overflow, right? You have, like 250, like basically you have, as an example, 255 and 1, like you have 2 registers, you add 255 and 1, and it wouldn't be, like obviously 256 doesn't, is not representable in the numerical range of an 8-bit register, so that would like unintuitively overflow, meaning for a 8-bit, like Commodore 64, 6505 or so, that, or 86 Intel or other 386, that would, the CPU would perform the addition, and because there are no more bits available, it would overflow. Extremely unintuitive for normal users or mathematicians or stuff, but that is simply how computers worked for 70 years. That is not ideal. I mean, it's in general not ideal, but it's specifically not ideal for image and audio data without. So what saturation does, it's also available in MMX and 3D Now and SSE and AVX. So for image and audio and stuff, 3D data, you don't want the stuff to overflow, right? So if you add stuff in images and white, like from 0, from black to white to 255, you don't want white to become black, right? Like if you add 2 images, like it would look like distorted garbage, right? So basically this bit simply indicates whether the last, or not like last, probably you would need to clear it manually. Like you probably could perform, it's not last, like it's only set on saturation. So it's not last, I should not say last instruction. Like basically you could clear this bit on the beginning of your operation. You could saturate all your image data or stuff, or perform all your 3D and image and audio processing and stuff. And like, let's say you added 2 images, and at the end of thousands of instructions executed, you could determine whether anything saturated, right? Anyway, so they added that for performance. Basically, it's, you could say why has one, like the saturation bit, 1 register, and wasting 63 of 64 bits for only 1 freaking bit. Obviously they could add more stuff later, but the reason is that's 2 independent stuff, right? Obviously the rounding mode, you could say like, why is this so wasteful? It's 2 completely different things, right? It's rounding mode and saturation. And that is why it's separate, wasting 63 plus 62, so 120 whatever bits. They combine this so that for task switching, for example, saving that, like you run Firefox on your CPU core, you task switch to whatever, your kernel, or or even in Firefox you have 2 browser tabs and you task switch between them, obviously. Or Pulse Audio, right? On you task switch, better example, you task switch from Firefox is running, rendering your web stuff, and Firefox is outputting audio data, obviously through Pulse Audio or Pipewire. The kernel task switches to Pipewire to do the audio processing there, and obviously those bits need to save, right? This is why Operating System 101, saving and restoring registers for CPU scheduling tasks, different tasks. So we need to save this, right? So they added that, I believe, at RISC-V vector extension 0.8, as far as I remember, or later 0.9.1, but I believe 0.8. They added this combined register, and so what I've done is, instead of using this 1 combined register of this 3 freaking bits, we use the non-combined register, right? So I added here a little bit more code. The problem is, so this should work, and that is why I believe the CPU has a bug. because I believe my changed code that is commented out here currently in restore and save. This is also why I have the CPU manual open here, this amazing overseas quality of low quality stuff. And I was reading around here in the freaking Xuan T-Head Alibaba thing, because this illegal instruction falls, right? They document this here as fixed point rounding mode register, but I believe it's maybe it's not. I don't know what's going on there. I need to do more research. Maybe it's not implemented. Maybe it's partially implemented. All I can say is right now this illegal instruction falls for no reason that I could see. It's documented here, but it's somehow not working. However, I believe it anyway works accidentally. I mean, in a real implementation, of course, the bits need to be saved and restored. But I believe that's not. This is rarely an issue, right? I mean, obviously, an operating system should protect all bits and stuff, but these are rarely used bits, right? Obviously, in a real stable production operating system, all even unimported, rarely used bits. I mean, and even if they are used, right? You do audio processing in Firefox Impulse Audio, you run some 10,000 or so of instructions for computing your audio data, like here going live to YouTube. Like if you task switch, then most processing is probably usually already done. Of course, most processing is usually done, is not good enough for a real operating system. However, I believe this works because the C906 core here of Xuan T-Head fame means this bit's also in the floating point control register. No, I lost my... cool, now my AMD GPU is glitching again. Amazing stuff. I probably should switch to live streaming from a... it's like every silicon is broken, right? Steam Deck. Desktop to... Hey, is this even recovered? Usually, maybe I should... Usually my OBS doesn't recover, so yeah, AMD 1. It's like you can't make it, also we can close it. Do I have my... Don't need... That probably should be better. So yeah, probably, I don't know if it was in some draft standard, because the problem is this 0.7.1 spec does not mention all the details. For example, it does not mention the floating point control register. So I don't know if there were other draft documents somewhere in other regular RISC-V either that would document this, because here in this vendor CPU spec they mentioned, oh come on, where is the freaking, when you want one thing, yeah, this how many pages? Yeah, 703 reduced instruction set, only 700 pages. Where's my F3? So this bits are document. I've not checked this yet, but oh, come on. The floating point, the regular floating point. Where is it even? Freaking extended user mode. Oh come on. I hate not finding bits quickly. So the bits are mirrored, apparently according to this documentation. The documentation, like they document also that VXRM. So who knows what's going on there? But given that they document that, oh come on, VX. I could of course test this another day. Here probably. So yeah, floating point control and status register VCSR, that is where, according to the RISC-V specification, the regular, not vector, but regular floating point occurred exceptions and rounding mode lives, and also like overseas low quality documentation at its finest. Please note, they mention here occurred exceptions flags and rounding mode, like 0 to 4 and 5 to 7, right? And nothing else, right? Like 0 and stuff. And then when you go here, so this is NX, UF, OF, so imprecise exception, underflow, overflow, divide by 0, NV here, NV invalid instruction operand exception, then rounding mode, and then they continue like basically here in this diagram you have rounding mode and then 0, right? Like amazing documentation continuation, because then it's like, hey, VX set saturation vector overflow flag bit and VX RM. So most likely, I mean, according to this disagreeing information here, we probably don't need this on the 0.7 draft, but I would need to check other Internet Archive, Wayback Machine and stuff, whether it was specified as that and other 0.7.1 Silicon implemented the same. So, I me't it obviously is in disagreement with the specification that VXRM, that, I mean, these registers are documented. Appendix C, control registers, chapter 15, but the illegal instruction fault, so yeah. But that is theoretically how it should be done. Introducing, I could have done this in assembly, but it's like I like to do stuff in high-level languages, so I do like here, because the issue is, I mean, okay, this, yeah, what I could have done in assembly, shift what, so what I'm doing here is replicating that behavior, except it doesn't work anyway, right? So this code would read this register separately, shift it up one and OR it together, just how the new 0.8 extension and 1.0 final would represent this in hardware with this VCSR, but it doesn't. So yeah, and then of course restoring it, right? So instead of doing it in assembly, I do this here in a higher level glorified assembler portable macro preprocessor. That is C, shifting it down right again for VXRM and ending this one bit out there for VXZ, and then supplying it here to this GCC GNU GCC based assembler template of templating it in here for the third and fourth, basically counting from 0, so fourth and fifth argument effectively for VXZ. And so yeah, reading and writing this in kernel space throws a illegal instruction, as mentioned, illegal instruction exception. I should test this in user space, whether it, I mean, yeah, the problem is, yeah, I mean, these bits are mirrored there, so yeah, maybe the, and that is what I mean when I the other day wondered, like, and that is questionable CPU quality, right? In AAA, I mean, not only Intel and AMD stuff has stuff broken, but usually credit where credit is due with their overly complex x86 CPUs. At least all the bits usually does work. I mean, give me, like, if you are an x86 overly complex instruction set master guru, leave me in the comments below if there were ever bits documented that did not work in silicon. I mean, sure, Meltdown Spectre, they had speculation and Meltdown and stuff and so on, but like with extreme bit hammering and so on, but not like with like regular normal use of bits not working. Although sure, there was Pop A, 386 Pop A or so, Pop E. There were some curious bits at times behaving different between 8086, 286, 386 and Cyrix and stuff, but entirely registers not being there as documented, that is a new one, even to me. And that is why in general, yeah, why I didn't spend too much time the last decade on questionable CPUs. Anyway, moving on. There was one more thing. So with all of this stuff, this was still not working, right? I still got illegal instructions. By the way, so if you have, do I still have? Oh no, I don't, because it scrolls away. What I then usually did, so if like pro tip, so then I had here, so usually this was often faulting in, for example, schedule, and then what you do is, like, if you, of course there are debuggers and Linux kernel-based automated scripting of matching stuff. But like if this would be faulting, you would have a fault address, and then you could match that to your disassembly of your kernel and match this address. For example, if you build a kernel with all symbols, at least you would get a Linux kernel printout of, hey, you are, by the way, I should have this in, actually can show you that, in varlog messages, because obviously, it also terminal, external color, because obviously, and so then you would have somewhere, oh cool, also garbage, here, stop scrolling, this is serial, 115,000 baud. Oh, come on, stop scrolling already. Schedule. Oh, come on. You know what? I need to. This serial terminal sucks. 244, I believe. Oh wait, we probably don't have fconfig root. Oops. And then let's become root with the test password and varlog messages. It will scroll much nicer and snappier and stuff. So yeah, here are some, and do task that, no, not do task that. And there also you need to guru meditate, then usually like you need to be careful to look at the first oops, because the second or third or infinite more occurring after that might be a follow-up issue that is not your primary reasoning. Here we have schedule plus 462 hex of program RVV string copy. Here, oops, illegal instruction in kernel. Here, cause illegal instruction schedule. Schedule 462. Then you would need to use this address, this start of function plus 462 something. That of course will bring us here. All right, this, I'm not sure if this might not be the right disassembly. What was the, so for example, CSSR here, and you would then have something. So yeah, this disassembly probably doesn't have, this is a new disassembly, but so then you would have a CSRR A6 or so, it's just a random register of VXRM, for example. So yeah, whatever, CPU is broken, yeah. What to expect from a 0.7.1-draft implementation. But again, all is not lost. We don't really need this register. We can use the other bits that hopefully are there. But that was still not all, right? There was one more thing, one more draft thing. And so with 4 or 5 hours in, I was still wondering, like, why the freaking heck does it still not work, right? Why do I get still illegal instruction? Turns out the floating point stuff was not enabled because the and that is the rest of the diff here. Turns out after some more guru meditation and the usual stuff you do, developing your microkernel or tweaking, fiddling around on your single address based monolithic Linux kernel, it's like, why do I, like, also, like, this tool stuff was totally time consuming because I didn't know what exactly is buggy here, right? So like, I could have debugged hours more. Also, pro tip, then I disabled the offending instructions, like, okay, fine, we don't need it. Let's disable it first and continue and guru meditate further. And that was a really, truly genius move, because it turns out I got still illegal instruction and stuff on this vector instructions. And basically they were infinitely illegal instructing there, illegal instruction faulting. Basically a very fast kernel oops generator. And it turns out they changed also, and that is not documented here, to my surprise, and that was like this took another hour, right? I can't make this shit up, right? 1 hour there, 1 hour there, 2 hours there, and at the end of the day, the whole day is over. When my embedded customers, like 10 years ago, when I did more embedded Linux development, it's like, you quote like, yeah, this will probably take 40 hours. And then after 40 hours, like, yeah, it's, dear customer, I'm happy to report it's half working. We are 90% there, but we probably need another 40 hours. It's like, how dare you? You need more than 40 hours to get this shit ARM or PowerPC silicon working. It's like, hey dude, it's like, we didn't make this bloody silicon and the documentation is halfway broken. Because that is also my recurring, actually not really fun with, like, if you do this low level stuff, which, spoiler alert, why I have not done that much embedded stuff the last decade, because if you already, like in my experience, like leave me in the comments below, like when I, of course, 25 years soon experience, or not soon, 25 years experience, and I already usually doubled stuff, right? Also, we often didn't get projects like a decade ago because I, with my experience working on some ARM PowerPC stuff, like customer calls like, hey, we want to do some ARM stuff for our Sony smartphone or Volkswagen shit. And just illustration purposes only, right? And then with my experience, like, okay, fine, it's some hour there, some hours there, let's double it, right? What I've always done then, I always, like, because obviously most technicians and scientists and stuff often over optimistic, right? But although after 25 years, I'm not over, like, why am I so negative? Because for 25 years, no, everything is broken. You have a shiny RISC-V CPU, this registers don't work, and it's like, and there also, by the way, there's another bug in this documentation, like some registers documented to read 0, which I believe is wrong. I forgot which one it was. Like one of those registers somewhere mentioned zeros, like, yeah, documentation. So I always doubled it, right? When I thought, okay, that's some easy job, like just some bits here and there, I probably need 8 hours, like a day or so, I always doubled it, right? And even then, sometimes it didn't work, right? Sometimes you think 8 hours and then, like, yeah, so you think 8 hours, you double it. If you're lucky, you win the project. You double it to 16 hours, right? 2 days. And even then, sometimes I didn't get some shit work in 16 freaking hours. Like when I thought I doubled already my estimate, right? Which, by the way, in general, in IT or other stuff, like, I really hate when, like, customers get angry and freak out. It's like, hey, we do our best, we have experience, and often shit doesn't work, right? It's not like you can't work better than perfect, right? And hey, you brought the silicon, it's not ours. And that's probably why I also want to fully formally verify your freaking silicon, which obviously, spoiler alert, I don't have the impression T-Head Semiconductor did for their Shuran T-Core. So, because the last hours of Google meditation, and then it finally freaking worked, was they changed this vector extension enable dirty and initial state bits. What are those? So those are similar to the directly mirroring the floating point. It is also similar to all other CPUs like x86 and PowerPC. So you want to control whether your kernel or user space processes even are allowed to use those instructions, right? For example, in the kernel, most kernels, including the Linux kernel, usually disable floating point and vector extension because the kernel, for performance reasons, doesn't want to save all those huge floating point and vector state, right? Because if you task switch from your user space Firefox process to the kernel to do some network I/O or so, of course it improves performance if you usually don't need floating point to not save the floating point state, right? So the kernel, like the Firefox, has a system call, it schedules to the kernel, and then the kernel code would run with floating point disabled so that it doesn't accidentally run something, so that the kernel would get an illegal instruction fault instead of clobbering the Firefox, because the kernel would then continue, like the CPU would continue to run in supervisor kernel ring 0 or whatever x86 PowerPC equivalent with the floating point registers values from Firefox, but with the floating point instruction is disabled not to accidentally clobber the floating point state of the precious user space process that is Firefox. That works the same usually for all operating systems, including Windows, Mac OS, and BSDs. And so that, therefore, of course, there are bits here, and to my surprise, they changed this, right? And that is not really documented because absolutely crazy. So that is vector context status in M status, vector context status field VS is added to M status, by the way, 0, so this shadowed in S status 10 to 9, and attempts to execute any instruction or access to vector CSR raise an illegal instruction exception when M state VS is set to off. That is VS vector state. And they changed that between vector status and VS status. They changed those bit definitions between 0.7 and 1 final, and that are those bits that are changed here. And because the original 0.7 draft doesn't even mention that, right? At least as far as I've tried to find yesterday. So maybe they documented this in some other general privileged either draft document, because it's not in there. I looked yesterday, I don't need to do that now. And so only checking this then here, this is QRT C906 specification here. I then found that, no, this is somewhere, where is it even? That is the other 30, oops, no, I didn't want to turn my bloody PDF document, shit. 30, like, yeah, of course, like Control LOR needs to rotate left and right. It's like an amazing UI design. Somewhere again, yeah. So this changed from absolutely crazy also, this vector status here. They apparently, these bits were apparently earlier specified to be very high. And they were then changed in this process, in this standardization process, to much lower bits. I wondered that those bits were free there. I also don't quite get, for me it's a little bit strange. I mean, as per usual, there were probably totally amazing reasons. Yeah, as the last Ubuntu server built compatible with MongoPy Pro Summer, slowed down CPU 2.6. I've no idea. I don't run Ubuntu server. Also comments there. So yeah, welcome everyone. Comments there. The position of VS wasn't specified in the. So yeah, you say it wasn't. Yeah, it was not in the document. You agree. And so this took quite a while. It's like you basically, that is the thing, right? You read the specification. I mean, obviously you can't remember each bit and stuff. And you also, I totally didn't expect this, right? You debug and guru meditate and compare back and write, and then like 1 or 2 hours later, it's like why is this bloody bit on another, yet another bit on another location? So yeah, as commented there, summer wasn't specified. It's not in the 0.7 draft here. And yeah, whatever. I wonder if they call this, I believe they didn't call it SRVR, so they come vector. Probably you should use a, wait, there was, I probably had it on the screen when, here. Maybe, yeah, here we have it, control registers. It's probably this one. And yeah, as I just explained, so that is a general machine status register, and we can check, so M status, the vector context status field. So this is 1, 0 final release candidate, or how do they call it, final? They write here M status 10, 9, bits 9 to 10, and 9 to 10 are 0. So these are the bits that are in the final. So I've no idea. For me, it's also, yeah, if you know the reason why they changed it, this is also the point, like, why did they had to change it, right? I mean, there was a QEMU implementation, there was a GCC implementation, there was Linux kernel early patch and stuff, and I believe I have this early patch still up somewhere. It's like basically all the stuff I have here, it's like, yeah, here, like I googled everything, like maybe, no, not this one, because then in this early patches, this is one of the early patches from over 2 years ago, it's like here. And so adding this here, and it's like eventually it's like why are these bits on another place, right? And so this took another hour or two. And so yeah, this is vector state. So as you see here, in this patch, this bits 18 hex here at the top, that obviously are exactly those bits here, 23 and 24. These bits are by this CPU documented as 0. These are 10 and 9 are the bits as documented in the 1.0 specification. And this is a change of here 6 hex for 2 and 4, very early in the early bits of 9 to 10 is documented. Like, yeah. So in the end, it works. Let's, I believe I had this on the screen already. So it is possible, long story short, it is possible. This CPU, this particular 0.7.1-draft implementation appears to have some implementation bugs. Who is surprised? Although I am surprised that something as simple as those registers don't work. The other instructions appear to work as used here by this example, string copy and mem copy. The patches, as much as the RISC-V overlords might hate it, the changes necessary to support this are minimal, as seen here by my customers, right? We paid 16 hours, why are there only so few changes? It's like due we researched, debugged, and guru meditated and debugged for. It's like it's yet another very expensive few liners of making hardware silicon work. And then my customers, you quoted us 8 hours, it took 16 hours, and now those patches only 7 lines. It's like dude, it was it takes to crawl through. It's like reading freaking specifications, guru meditating, and debugging, similar to security vulnerability, Spectre Meltdown, certainly a few line patches for hundreds, thousands here and there. Yeah, I'm at the end of the week, I'm thrilled and happy that I managed to successfully complete this week's challenge of not only booting my own self-compiled kernel, but even enabling what all the RISC-V masterminds and upstream Linux kernel people frown upon and don't want to see working, and argue like, yeah, this few million devices will be nothing in the grand total scheme of Internet of Thing and devices shipped in years to come. Yet, as of today, that is probably the only RISC-V vector extension silicon that you can buy with your hard-earned money, even for cheap. So yeah, as seen here, the performance is of course vastly superior, saturating up to 3 GB per second apparently, here at times of course to the CPU caches, because otherwise memory DRAM limited at 1 gigabyte a second for this low performance IoT silicon. So yeah, 1, 0. So you see here, like even for mem copy performance is even more dramatic than string copy, right? Because mem copy is of course easier than string copy, because string copy needs to search for the terminating 0. And here's the performance. If we see here, it's like, yeah, it's scrolling away. Let's scroll up a little bit. So that is, it's like 32. That is, it's like, yeah, do you want 300 or 3000 megabyte per, wait a second, is it even the right line? 32. Oh no, it's not 3000. Do you want 300 or 1300? It's like, do you want a gigabyte second more memory copy or not? Yeah, so going forward, so the good news is maintaining, in my opinion, maintaining this support. And by the way, you don't even need an old binutils in GCC, because what I do here is I misuse the new instruction encoding for tail and mask. What was it? Tail and TU undisturbed mask. Yeah, vector mask. So you don't even need to use a decade-old example, a few years old experimental binutils draft git branch that was deleted. I'm simply using, because instruction encoding is otherwise entirely different, except these new bits. If we simply set them to 0, it will obviously just compile, assemble, and result in the same instruction as compatible as a 0.7.1 draft implementation. And of course, so using that in user space, so what does it give? That gives us higher performance, and if we are careful, of course, we can't use everything, right? You can't use the latest and greatest GCC auto-vectorizing GCC because it will generate instructions incompatible. However, if you could either patch GCC, which, spoiler alert, maybe we will do soon, another month, share, like, subscribe. You can also you could either use the old binutils that makes it a tiny little bit easier. However, I would makes it a little bit easier of more directly getting what you want to. However, I would suggest rather use the new GCC and binutils, making it easier in a different way of, you need to write different instruction as presented in the 0.7 draft. But it's like basically using the new instruction names, and just be careful of what you're doing, and for example, setting the vector masks differently, right? Because they are, so it's a little bit more error prone to set the old 0.7 draft compatible vector element and masks, because they are one bit off and so on, right? But in this simple case, right, and that is what makes me somewhat sad, and I don't quite understand. In my opinion, it could have easily be avoided, that changing so many last minute bits, even including the machine status or the vector context status in M status. It's like, why did they have to change that too? It's like, dude, seriously. And maybe the bits are used for something else. But long story short, for example, the string and memcopy, as long as we use 8-bit elements, they are even entirely compatible, right? So what gives in the end, with a minimal patch, you can use at least 8-bit element vector, string, and memcopy identical between 0.7 and 1 final, and the kernel patch is minimal, right? It's like, yeah, we can't support this. It's like, dude, this unsuccessful YouTuber here did this in just okay 8 hours to get the kernel working, plus 6 hours to get this working. Theoretically, yes, it is ugly. I agree. It is ugly because the RISC standardization process made it ugly, right? of these bits. Of course, you can use these bits dynamically, right? You can, instead of having it hard-coded, you could have SR vector status 1 and 0.7 and have a global variable like a long, unsigned long, read mostly vector status bits, and yes, performance. Hey, it's just loading one freaking global variable. It will not kill your performance that much, right? You could even ifdef to if portable kernel, then load the global vector status bits. And if you don't compile in all winner or D1 T-hat stuff, then ifdef the fixed one final bit mask. Long story short, it is not impossible to support. Yes, it's a little bit ugly, but so much code on Linux kernel is ugly. Just look on all the ugly x86 code or stuff. So it's like, yeah. One more hack. It's like the Linux kernel is so full of hacks and workarounds and security mitigations. It's like this, yeah. So yeah, it's possible. If you want this patch, drop me a note. If you have a position in Alibaba, T-hat Semiconductor, and want to support our work, there's a PayPal donation link at OnlyFans and Patreon. If you want to use the stuff for high performance computing in China, you know where my donation link is. I did all the work for you and tested it. Yeah, these bits need to be verified, so this would be another dynamic thing. You could have two ASM volatile here, so yes, performance, like basically one global vector state, either version thing of if 0.7, then use this assembly. You could even dynamically alternative patch that so that you don't have an overhead. You could theoretically even CPU alternatives as seen on x86, like SMP alternatives and other alternatives. You could even dynamically patch it. So much to performance my ass. You could dynamically patch your freaking kernel for whatever bit masks, and assembly code is like, hey, it's not like 100 freaking instructions, right? It's like 7 instructions in total, so it's not like copy these functions, patch them dynamically, problem solved. If you share, like, subscribe, Patreon, GoFundMe enough, then I could even one day, not this week, because this week I spent enough time on RISC-V vector extensions, and now my brain is populated with all the necessary high-performance SIMD vector extension RISC-V bits for the next years to come. And also, if you're wondering how do people become experts in SIMD vectorization stuff, like, hey, you just spend 16 hours a week on your tiny little RISC-V Linux hobby. This is how people become master Jedi guru meditators of bit whispering, bit ISA, CPU ISA, bit whispering live here on this channel. Yeah, cool stuff. What's next? Except getting it upstream. Getting it upstream, that was a good joke. Next is patching our glibc to enable that and see if it improves whole system performance using vectorized string copy for all your applications and making everything more snappy. And then also, actually, theoretically, we should check if those VXSet and VXRM bits are actually present in the floating point status register in this freakingly cursed and partially broken CPU. That's basically it for this summary. I hope you enjoyed this excessive deep dive of RISC-V vector extension changes and enablement. Don't forget to share, like, and subscribe, because you certainly don't want to miss the next low-level hackery and RISC-V PowerPC, SGI Octane, and general Linux enablement and microkernel work someday coming here live to this channel. Let's take one quick load here. There are other helpful comments, highly appreciated. I hope you appreciate this work too. Comments there. By the way, do you know about RVV rollback, which can be used to make RVV1 code compile under RVV01 toolchain? At least most code. No, I have not heard about that, but thanks for mentioning it. It doesn't surprise me. So which you say can make RVV1 code compile under RVV0. Okay, but I rather want the opposite, right? Thanks for this note. Noted. However, I would rather like to use the latest GCC, and I'm much more interested to use latest GCC in binutils, because that is obviously what we want to, because the other stuff is not maintained, right? So moving forward for the next decades to come, I rather do the opposite of, as seen here, creatively using or misusing the latest tool chains, the latest GCC, because of auto-vectorization coming. However, as there are some implementation differences in tail and masks and other grouped and so on element supports in 1.0 final, of course not all code would work, right? So to use upcoming, not yet fully upstream, but starting to upstream auto-vectorization, I would rather make that code work on 0.7 silicon, probably including patching GCC to disabling some unsupported vector grouping and stuff like that, and making sure shifting bits differently in binutils, certainly. So certainly requiring disabling some stuff in these GCC that is not supported in 0.7 silicon, and then also maybe patching some kind of hack into binutils of moving this mask bits to the 0.7 places or so. But that is stuff you would want to share, like, and subscribe for, because it is not something that's upstream yet and coming in the future. And you found that MVSGT-VX-V8 didn't work and gave an illegal instruction, while VMSGT-VX-V16-V8 worked. There are very likely a lot more of those types of bugs. Got a 26 speed up for UTF length functions with a simple Scala non-unrolled loop versus a simple vectorized implementation. That is amazing. If you want to share, like, if you want a link, like, you're welcome. All right, do YouTube. So in this bloody YouTube chat, links usually don't work, although I have not disabled them. Annoys me as well. I would hope that links do work in the regular old-fashioned comments below this video. But in either case, you are welcome to post links to your work, like UTF-8 processing, in the regular YouTube comments. I sometimes check sometimes I said it before, sometimes the bloody YouTube comments disappear, not even in the moderation system, right? For example, on the previous video, I have, like, YouTube shows like one comment more than I see. I have no idea where it went, so somehow YouTube comments disappear sometimes in dev null there, in their nirvana, bit nirvana, without me seeing them. Sometimes I see comments in the moderation, but some comments just disappear and I see them nowhere. Although YouTube sometimes shows a comment counter higher than the total accumulated number of comments. But like, if your comment doesn't show, post it again, or you are welcome to join our Discord as well. And yeah, so next I need to patch glibc and see how that performs. And in other assembly trickery and stuff, certainly welcome. And what else do we have here? Bobby D, as a computer science student who did data structure courses and algorithms, how to start to do kernel development, what's the way to start? I have this question often, and my standard answer is look into what interests you. Like just in this case, I got this silicon donated, and now I spend way more time since the silicon is worth getting stuff to work, which is, as much as it annoys me, otherwise welcome to make our Linux distribution a better place every day, and supporting what nobody else is willing to support, like SJ Octane, PS3, UltraSpark, and RISC-V vector extension draft. So my recommendation, look into what you're interested in. If you're interested in vector extension stuff, look into vector extension stuff, just like I do did. If you're interested in your P3, look into making P3 stuff more work, just like I do did. If you're interested in keeping your SGI Octane working, like I did, then look into that. If you're into storage, look into storage, and so on. If you're interested in 3D graphic, like basically, because it's also what I always found most people being the most motivated, because as per usual, if you get a boring assignment, you are not interested, you're not doing it. So that my top number one recommendation is always look into what is interesting for you, or alternatively, what does not work for you. If you have some stuff like this piece of shit proprietary DVI to USB 3.0, which I still need to reverse engineer because it doesn't have a whatever. So like if some stuff doesn't work for you, has a bug, then try to figure out this bug or reverse engineer some hardware that you would want to use and stuff like that. More common, that's fair. Personally, just want to write RVV1 code and test it on 0.7.1 board until, yeah, and that's also why did I waste so much time? I mean, I didn't expect to waste 8 time to get a custom kernel working. And by the way, which kernel do you use? Which code and kernel? Do you also use, by the way, are you then, as you commented, is there very few people working on this stuff? Are you by any chance Bruce Holt or something like that? Yeah, we can't find the Discord. So somehow Discord starts charging. So previously a non-expiring invitation thing was working. Now it doesn't anymore, which is certainly annoying because now they want to charge for non-expiring links. Where is the... here. Let's see what happens today. So I mean, I could share that one, but that will expire. But so previously it worked, and there are old links. I basically need to make a copy of my own link. Yeah, and now they want money for that. But there is one. By the way, do we? What is the expiry time? Let's see what happens. Let's use this one. 30 days is better than none. And yeah, no, I'm not binary patched Ubuntu server. What do you mean with you binary patched Ubuntu server to? You binary patched the kernel, but so do you have? So then do you just enable it and don't have task switching? Do you not like save and restore the vector state then? You can only run one user space process at a time, and if you run multiple, you clobber your registers, or did you binary patch in all the context switching? By the way, which silicon do you run? Do you probably also run a T-head Chuan T C906 or okay, so we run the same MongoPy MQ Pro. That is amazing. Okay, you don't have task switching. Fair enough. So you only enable the floating point bits. So basically the changed bits that I just outlined. Okay, so you don't have task switching. Okay, then you need to be careful, obviously, not to clobber your floating point state. Did you find any other things not working? Magic bits not. Did you read? Next I need to try. So what is next? Patching glibc, and I also need to figure out if reading those registers in user space also illegal. Instruction fault. So privilege they should be. So that is 0.7 spec VX set and RM. Privilege. So that should mean unprivileged, right? So yeah, I should check what those register reads. Unprivileged CSRs. Vector extension adds 32 vector registers and 6. And that is what bothers me a little bit. I mean, yeah, this is why I oversee silicon without formal verification, probably. It's like basically the beginning of this specification on page 8. Vector extension adds 32 vector registers and 6 unprivileged CSRs. And then at least those don't read and write for me in kernel. Yeah, quality engineering. That's it for this video. I hope you enjoyed this, learned something. Don't forget to subscribe, Patreon, YouTube membership, or PayPal sponsorship and stuff. And yeah, I will save this patch in T2, of course, for others to use. To use in production, I would need to implement either a global vector version thing, maybe next month or so. Don't forget to subscribe for that, and to be able to, like, otherwise if we start shipping stuff, it would illegal instruction fault and burn and hold and catch fire on other 1.0 final silicon. So obviously we can't ship that without further engineering. But that's it for this video. Have a good day or night. Hope you enjoyed this, learned something, and see you soon for all the next fun stuff to come.